Hello everyone, welcome back to our chemistry class. So this is the final subtopic for chapter 4, 4.5 metallic bonding part A. So in this video we'll be talking about metallic bonding, properties of metal and the factors affecting the strength of metallic bond. So metallic bond can be defined as the electrostatic force between the positively charged metallic ions and the sea of electrons. So this is the Electron Sea Model, in which the M+ is positive ions, while the electron is what we call as the delocalized valence electron. So actually, in a metallic bond, we imagine metal atoms as an array of positive ions immersed in a sea of delocalized valence electrons. So these delocalized electrons are not bound to individual atoms, and they can therefore serve to bind larger number of metal atoms together. So in case kamu ditanya dalam exam untuk melukis Electron Sea Model, okay, so kita akan guna sodium di sini sebagai contoh. So when sodium release electron, it will become sodium ion. Jadi sodium ion itu kita gambarkan dia sebagai dalam bentuk circle, and then kita labelkan setiap circle itu dengan sodium ion. And then elektron itu kita just letak di antara sodium ion tersebut, and then kita lukis satu border. Okay, selepas kita lukis satu border, kita labelkan sodium ion itu sebagai metal ion, dan kita labelkan elektron itu sebagai sea of delocalized electron. So ini apa yang kita panggil sebagai Electron Sea Model. Next, kita sambung properties of metal. So metal are shiny solids at room temperature except mercury, with characteristics of high melting point and densities. So mari kita tengok pula properties of metal daripada segi malleability and also ductility. So malleability ni adalah apabila metal itu kita boleh ketuk dia sampai dia boleh jadi satu keping macam sekeping kertas. Manakala ductility ini adalah apabila metal itu kita boleh tarik dia sampai dia jadi macam wayar. So as we discussed earlier, in metallic bonding, the electrons do not belong to any particular metal atom. So if sufficient force is applied to the metal, one layer of atom can slide over another without disrupting the metallic bonding. So dia macam ni, kita ada satu metal di situ. Bila kita kenakan daya, force is applied, one layer of atom tu dia akan slide over one another tanpa mengganggu itu metallic bonding. Therefore, this means that the metallic bonding is flexible and also strong. Thus, the metal can be hammered into sheets, ini adalah malleable, or drawn into wires, ini adalah ductile, without breaking. Next, daripada segi thermal and electrical conductivity. So we know that in metal we have delocalized electron. It is mobile and free to move away from negative electrode to a positive electrode when metal is subjected to electric potential. Therefore, metals have high electrical conductivity. The mobile electrons also can conduct heat by carrying kinetic energy from a hot part of the metal lattice to a cold one. So it has high thermal conductivity. Next, kita tengok pula daripada segi melting point. So kita tahu melting point of a metal indicates the strength of its metallic bonding in its structure. So strength of metallic bonding is directly proportional to the number of valence electron per atom over the atomic radius. So from this relationship, we know that there are two factors affecting the strength of metallic bonds. The first one is the number of valence electron, and the second one is the atomic radius. Therefore, when the number of valence electron is high, okay, the strength of the metallic bonding is also strong. Okay, in terms of atomic radius, when the atomic radius is small, the strength of metallic bonding will be increasing. So mari kita tengok effect of strength metallic bonding on melting point and also on boiling point. So kita ada sodium, magnesium and aluminium. Itu adalah elemen unsur di dalam period 3, manakala lithium, beryllium and boron itu adalah unsur di dalam period 2. So mari kita tengok trend daripada sodium ke aluminium, unsur di dalam period 3. So bila kita tengok melting point and boiling point increase, and this is due to the increasing of strength of metallic bonds. Okay, dan bila kita bandingkan trend ini dengan elemen di dalam period 2, okay, elemen di dalam period 2 also exhibit the same trend. Okay, this is because aluminium has the highest number of valence electron in period 3, therefore it has the strongest metallic bonding. More energy is needed to overcome the strong bond, and this will make aluminium has the highest melting point and boiling point in period 3. Next, when we compare the elements in period 2 and also elements in period 3, we can see that the elements in period 2 have a higher melting point and boiling point compared to the period 3. This is because elements in period 2 have a smaller atomic radius, stronger metallic bonding. Therefore, more energy is needed to overcome the strong bond, and this will make elements in period 2 has the highest melting point and boiling point. So, when we go down a group, the size will be increasing. The metallic bond will become weaker, and that is why the melting point and boiling point of sodium is lower than lithium. So that's all for this video. I'll see you in the next video for part B, metallic bonding. Take care and bye-bye.